Hi everyone, and welcome to today's online training session on how to improve the quality of drone mapping project. So my name is Photogrammetric, and I'm the Photogrammetric Workflow Specialist here at SimActive. So today the topic of the presentation is just to show you a bit some tips that you can use for your mapping project in order to improve the overall accuracy and quality of those projects. So the presentation will go as it is. So you'll learn first of all the basics of photogrammetry. So I'll just do a quick overview of what is photogrammetry, how it works. Then we'll start about collecting optimal drone imagery, performing quality control on the raw data, reviewing the correlator 3D processing option, and then a real-world scenario with some common mistakes and how to fix them. And finally, we will finish with some questions. So first of all, let's start with the basics of photogrammetry. What is photogrammetry? So photogrammetry traditionally is extraction of a three-dimensional measurement from a two-dimensional data. So basically, it needs to have the same point of view on two different images in order to be able to extract the 3D coordinates from those two images. So common features are identified within a block of images. So between 5, 6, or 7 images, some features are getting extracted because they're seen from many points of view, and from those different points of view, we're able to triangulate, so to create a line of sight in between all those points to the 3D coordinates in order to map accurately this the surface you're flying with your UAV. Also, there's the concept of parallax, which is basically the apparent displacement of an object from two different points of view. So how you see the object from two consecutive images is what we call basically the parallax. Another thing that's really important with UAV project is the quality of input data is key to generating good mapping product. So the next few slides, I will show you some tips on what to focus when you're planning your project and also when you're processing your project. So this way you'll make sure to have the best output possible. So now here are the mapping principles. So what are the requirements for photogrammetry? First and foremost, the first thing you need is overlapping images. So in order to be able to extract some 3D coordinates from your 2D images, you need to have some sort of overlap between your images. There's two types of overlap: the front overlap, so what amount of overlap you have in between two consecutive images, and the side overlap is basically the overlap that you're seeing from two different flight lines. So with UAV processing, we usually suggest having 70% front lap and 50% side lap. Those are the minimum requirements that you should use for UAV. Don't go below that because you'll just end up having more trouble to tie all your block together. Also, in some specific condition, you can even though raise up this overlap, maybe go up to 80%. 85%, 90 maximum, because you don't want to have too much overlap because it's going to create too much data. And for the side overlap, you can go up to maybe 75, 80%. Also, another good thing is when you're acquiring your data, it's always better to get more during the acquisition than less, because when you're going to come back to the office, it's going to be rather more simple to just remove one image out of two if your overlap is too greater than creating multiple tie points because you only have maybe 40% overlap. So always trying to plan a little bit above what you were targeting in order to have good results. Another thing that's important is to have parallel flight lines. So when you're planning your mission, your mission, you can also use a mission planner in order to have parallel flight lines. So this way you'll make sure that the overlap is consistent throughout all the project, and you should not have any issue during the arrow triangulation of the project. Finally, the other thing that's important is usually have the same elevation or have a constant GSD throughout all the project. So the GSD is basically the size of a pixel that you can see on the ground from your images. So the spatial resolution of a pixel on the ground. When you're targeting a project, you'll probably know what resolution you want to have for this specific project. So when you're planning your mission, make sure that this value, so the GSD, is quite consistent throughout all your project, even though if you have some terrain variation in your area, because the terrain variation will have an effect on the ground sample distance. So sometimes if you have if you're flying an area where you have a lot of slopes or features that have really high elevation changes, you may want to use a flight planner that's going to give you the opportunity to do a follow terrain option. So it's gonna follow the terrain. Try as much as possible to keep a constant GSD throughout the project. If it's not the case, what you can always do is always try to fly in different blocks your project. So all the sections that are the similar elevation, you can do one block there. Then if you have a slope, you can just raise up the drone elevation and then map the other section, and always go like this if your flight planner doesn't have this follow terrain option. Also, if you want to include oblique imagery, at this point you can change the elevation to texturize your 3D model, because with Correlator 3D, the oblique imagery is there only to texturize your mesh. So you can have, maybe, as we can see on the screen, 2 different elevations. So a higher one with an angle of 30 degrees, and the other one a bit lower at 45 degrees. So this way you'll make sure that you'll cover the whole building in order to really have a good texture in the bottom of the bottom of the building. When you're planning project for mapping purposes, it's always good to have nadir imagery. So when as we can see on the left screen here, as much as possible, try to have nadir imagery, so top down, and do not try to include any oblique imagery when you're trying to do some mapping purposes. Only if you want to generate some 3D models. Now, how you can choose your hardware in order to have good output. So for the drone, what you want is probably a larger platform. So you want to have something that's stable throughout your flight. You don't want to use a really small drone that can be really highly affected by the wind, because typically this could have an effect on the overall overlap of your project. So you want to have something that's either a fixed wing or a quadcopter that's quite big, so you have a larger platform. You also want to have a gimbal for the camera, so the camera is really stable throughout all the project. As for the camera, you want to use proper parameters for the type of project you're flying and the condition you're flying in. So make sure that before doing your whole mission, check your camera parameters, such as the shutter speed, the ISO. So you'll make sure that your images are sharp and not blurry, and not too dark or not too overexposed or underexposed. Also, you don't want to use fisheye lens, are never too good for photogrammetry. So you maybe want to get far from those types of camera if you want to do good mapping product. And you can also maybe favor large sensor size, since it's gonna have a bigger coverage. and also it's gonna have cleaner images instead of maybe 10 megapixel camera. So so those are also elements to keep in mind when you're choosing your hardware. Other elements also are GPS information, such as maybe you're targeting a really high accurate project, so you want to use maybe RTK or PPK correction for the drone. Otherwise, you can also use some ground control points if you want to have a better overall accuracy of your project. But the most important is basically having a correctly synchronized camera with the GPS. Here at SimActive, we've processed many thousands of projects, and we've seen some projects where where there's a lag between the GPS and the camera stamps. So sometimes this gonna have an effect on the overall process. So now we've talked a bit about the hardware. Let's talk about how to fly a drone mission. So first and foremost, you should use a mission flight planner to fly your mission. This way, you'll have a proper overlap. It's going to be really simple to set up your flight mission. If you're targeting an area, also always survey just a bit more than this area. This way, you'll make sure that you'll cover your whole project area. So that's another key point that people usually forgot. So they always survey just a bit smaller than what they need for their project. So don't hesitate to go just a bit larger than your areas of interest. The mission planner will also give you some consistent overlap. It's also going to have a proper drone speed for the type of project you're having. So this way you'll make sure that the camera rate is good for the numbers of images you're acquiring. Also plan your project on different depending on the camera, on the terrain, or on the size of the project. So if you're targeting, let's say, a forest or areas where features are maybe or it's homogeneous features, you might want to raise your overlap to have more redundancy in your project. So this way you'll make sure that when you're going to do the tie point extraction, it should be a bit more easier to tie all those images together. I know it's kind of not intuitive because more images may take longer to process, but at the end, it's gonna save you some time on the editing for the aerial triangulation module. Other elements that are quite important, the type of terrain you're targeting. So take into account if you have some variation of elevation in your project. So you'll make sure that you have a constant ground sample distance for your project. One thing that's also really important is the time of when you're going to fly your project. Make sure that you're flying around from 10 to 2 p.m. Those should be the timeline you should target if you wanna have good weather condition, because you don't want to have too much shadows during your acquisition, because those may impact the output you'll get with your mapping product. Also, you want to get it as much as possible close to noon. You don't want to have too much clouds. You want to have a light that's quite homogeneous throughout the flight. Also, not too much wind, and so because the wind is going to have an effect on the overlap. If you have a strong wind, maybe the drone might drift off a bit from his flight line, so it's going to have an effect on the overlap. Also, look at the battery if you have enough battery to do the whole coverage. So the type of camera you're using, what is the what is the ground sample distance you're aiming to. And also, if you're using ground control points, well, make sure that your ground control points are well distributed over your project of interest, because this way you'll make sure that the overall accuracy is well distributed over the block. We've seen some project before where maybe on a project of 800 to 900 images, well, we had 4 ground control points, but they were only on one side of the project. So make sure that those ground control points, they're all distributed throughout the AOI, so you have good accuracy overall all your project. So now let's talk a bit about the pre-processing of raw data. So here's an example of what you should not do with some UAV images. So this is an example where a customer flew with manual way, so there's no consistent overlap. Some images that are not related to photogrammetric processing were kept in the project. The ground sample distance is not really consistent throughout the project. So it's always good to do a cleanup before the processing of the photogrammetric dataset. So what you want to avoid is maybe blurry images. So depending on how fast the drone was flying, or the shutter speed of your camera, try to have as more sharp images as possible. If you have some blurry images, feel free to remove them before the processing of your project. This way they won't affect the mosaic or also the image matching capacity for your project. Sometimes also corrupted files. We've seen images that were taken, but only half of the images was saved on the SD card. So try to avoid to have corrupted files. Also remove landing and takeoff and turn photos. Sometimes landing and takeoff are quite obvious, but turning photos are sometimes left in project, and they can create larger residual on the side of your project. So when you're, I'll show you an example later on in this presentation, but what you want to do is basically remove the images when the drone is taking or landing, because sometimes the drone is taking pictures as soon as the mission is starting, even if it's not to the first waypoint yet. But also when the drone is turning from the first flight line to the next one, it creates some images where you can see quite far from the areas of interest, where it's not the best condition to play with those images. So maybe remove the images where the drone is turning at the end of the flight line. You'll see sometimes that the yaw or the kappa of the drone will change a bit, and also the pitch and the roll, or the omega and the phi, might be a bit more higher than the rest of those images. So you can remove those images. Also remove low angle oblique imagery. So you don't want to have images where you see the horizons really far, because this way you'll just have more trouble to find features in those images and match them with the rest of the project. And also it should just create enormous file if you're trying to ortho rectify images that you see really far from the horizon. Well, it just won't be able to ortho rectify such images. And also just a fun one, but don't try to put selfies in your mapping project, since it's not belong there. So now let's talk a bit about the photogrammetric workflow that is used in Correlator 3D. So we're gonna have here basically 3 different modules with different add-ons. So in Correlator 3D, we have a modular architecture with 3 big modules. So we have the first module, which is the arrow triangulation, which consists of finding key points between all the images. So have a nice block of stable images. You want to make sure that all your images are nicely tied together. And also at this point, you can import some ground control points, and we're going to refine the position and also the parameter of the camera. The second module is the surface and terrain model extraction. So the DEM extraction module, which allows the user to create surface model, point clouds, and terrain model. Then we have the mosaic or the mosaic module, which is basically the ortho rectification of images and also the mosaic creation with those individual ortho. Each of those modules also has some small add-ons. So for the arrow triangulation, we have a module to edit the type point editing. Also, just a quick note: we've released a new version of the software this week, and we have added new capacities to the type point editing. So it's kind of more. It's gonna be easier to create type points and to have to mark them in multiple images. Also, we have modified and added a new tools to create some GCPs directly from external source such as LiDAR or reference ortho. And so for the DM editing module, we have the DM editing modules that allows you to edit the surface model, the terrain model, and to get the best result possible. And for the ortho and mosaic module, we have the mosaic editing module, which allows the users to edit the seam line and color balance the overall mosaic. Finally, we have also a module to generate 3D texturized mesh. So we can take the input surface model, and from this surface model, generate a 3D mesh that will be texturized with the input images of this mesh. If you're using at this point Oblique Imagery also, what you'll do is you'll generate the AT with the nadir and Oblique Imagery, and you're going to disable, which I'll talk later in this presentation, the Oblique Imagery. Then you'll generate the DSM, the DTM, the ortho, and the mosaic, and then you'll re-able the Oblique Imagery to texturize the 3D model with the nadir and the Oblique Imagery. So now let's jump into real world scenario and see what were the common mistakes that were done. And now you can probably fix those cases. So the first one is basically a simple one. The customer had flown with manual way. There's no flying. There's no mission planner that was used for this project. So the overlap is really inconsistent. The GSD is not constant throughout the project. The images are not the flight lines are not parallel. So probably I would tell these customers either try to refly the mission with a good mission planner and parallel flight lines. Otherwise, it's going to be hard to really all tie those images together. So if you're looking for mapping purposes, what you can do is have nadir imagery for the DSM, the ortho, and the mosaic creation, and then you can use also oblique imagery if you want to include them to texturize your overall 3D mesh. The other one is basically a project that's fly only with oblique imagery. So as we can see here, we have an example of very low oblique angle. So we can see really far from the real point of view. So sometimes those images should not belong really much into the typical photogrammetry processing. If you want to use those images, maybe lower down the angle of the camera, maximum 45 degrees if you want to integrate oblique imagery. But to have a good mapping product, you need some nadir imagery. So first of all, do a flight with all the nadir imagery, then reduce a bit the oblique angle of this project, because otherwise, if you're seeing some blue skies, well, some blue skies, you'll see them in all the images. So it's going to be really hard to find common features within all those images. So it can just mix up the project during the aerial triangulation. So yeah, so as we see now, the real world scenario number 3 is either corrupted or blurry images. So the blurry images, as we can see here, the image itself is okay, but when we're gonna try to find features and match them with other images, those type of images it's not really recommended, because it's gonna just mix up the feature extraction. So either in this case, the shutter speed or the ISO was not properly used for the weather condition, or the flying speed that was used. So probably sometimes just fly the drone a bit slower can probably help us to have less blurry images. On the other case here, we see a part of the drone. So when the speed is too high or the drone is turning, well, as much as possible, try to avoid such images and remove those images prior to do the processing of those images. So just a quick how to fix those, maybe. Yeah, so as I said, flying at lower speed, having a clean camera, a good camera, and good camera parameters also. So before doing your project, maybe just raise the drone at the elevation that it should be, then take a few pictures, make sure that those are in good condition, so the light exposition is good, they're not blurry. So you'll make sure that you have good images, because there's nothing more frustrating when flying a mission and then coming back and then realize that your images are out of focus or they're quite blurry because the ISO or the shutter speed parameters were not correctly used for such project. So finally, last real world scenario case before the live demo is basically unnecessarily images such as takeoff, landing, or turning images. So what you want to use is basically you want to remove those turning images. I will show you a way that you can quickly remove the images from a Correlator 3D project. So what I've used here when I do the cleaning of the project that I process. So and I'll show you how you should set up your project for a typical or for an optimal UAV workflow. So also here we have an example of integration of oblique and nadir imagery. So we have a circle which includes some oblique imagery, and we have a cross grid that include nadir imagery. So so let's see how we can clean up the raw data set and remove those unnecessarily images. So as we can see here, we have the visual interface of Correlator 3D. So we have on the top of the screen here, we have different buttons. So we have the two first buttons, which are open and close project. Then we have we have the automated workflow. So the automated workflow is going to go through all the steps with a one button click solution. So it's really easy for the user that's not too familiar with the photogrammetry to generate quickly results. So you can also play a bit with those options. And then we have the options. We have the options to have different module one by one. So you can have the AT module, then the DSM, the DEM generation, the ortho mosaic creation, and the 3D model generation. So so as we have here, we have a circle that include the oblique imagery. So I can show you here an example of the oblique imagery. So we can see that the angle is not too far, so we're able to see the side of the building. Also, if you want to have good texture or better texture, really on the bottom side of the building, another ring at the lower altitude with the higher, just a bit higher camera angle could have been used, but it's fairly a good start if you want to integrate oblique and nadir imagery. So also we have a cross grid configuration. With Correlator 3D, we don't necessarily need a cross grid configuration. Only parallel flight line should be sufficient for such project. Also, for the mosaic creation, maybe you can only use the images that are only in one side instead of using all these images. You also save some on the processing time. So a quick way here to clean up a data set maybe would be to create a data set with create a project with all the input imagery that you have flown, and from there visually you'll be able to see your flying pattern, and you'll be able to select maybe some images that does not correspond to what you want to map. So in this case, if I would like, let's say, to remove a few images, what you can do is you can either select one images like this, and then you can quickly toggle them off like this, or you can do a multiple selection. So you can hold one selection like this, and then with the shift button, you can select multiple one, or control if you want to do multiple selections that are not one after the other one. And then by taking them off like this, you'll be able to see a way of cleaning the data set. So what you want to do is you want to maybe clean up the data set. You want to remove the images that you don't want to have here. So let's say in this case, I would probably remove those two images, so this one and this one, and then once the cleaning is done, what I usually do is basically I'm gonna open the image folder. So I'm gonna have the image folder that is right here. So and then from there, you can open the software, have this here, and then all you have to do is quickly scroll down here, and at the same time select the images that you want to get rid of. So it's going to be fairly quickly to do. I know for larger project it probably can be time consuming to do, but at the end, if you're not doing the work now, you'll probably end up doing more edition to compensate for image that should not have been in your project. So you rather better remove those images before doing all the processing, because it's going to save you some time for all the other module. It's going to remove some images, so it's going to be also quicker to process, and so on and so on. And what I do is I'm going to take those images and I'm going to cut them into maybe a folder that I've called image deleted, and all those images that I don't want to have in my project, I'm just going to put them into a separate folder like this. Then once this is done, I'm just going to recreate a project with the correct image folder, and I'm going to be good to go for the processing. So this way I'll end it up with a nice project that should be good to go. Then another thing that's important if you're playing with nadir and oblique imagery at the same time is you don't want to use the oblique imagery to generate the DEM, the DSM, and the ortho mosaic, since those products are usually used with nadir imagery. So what you want to do is you would like to do the AT with all the input imagery. So you're gonna go into your AT module, and then you'll see that the software was able to find many links between those images. So we're able to converge to a good solution when it's time to do the bundle adjustment. Then you can review the overall quality report of your project to make sure that everything that you've got was fairly consistent for a good project. Also, other element that you can look at here, the image type point, going to give you some information about the residual information of your project. We can see here 144.4 type points per image. This means that the overlap was fairly high. So sometimes this is an indication of how big is your overlap because there's a lot of redundancy. Depending on the feature you're trying to map, sometimes it's worth to have a lot of overlap. But for this specific type of project, probably parallel flight line would have been really sufficient for mapping purposes. Then I have a good AT solution, and I want to jump out to the DSM and DEM editing modules, but I would like to remove the oblique imagery from the processing. So the oblique imagery here is the last flight line of my group. So I can see here if I toggle off, toggle on. When I hovering my mouse over the flight line name, I would have here the disable flight line button. So by clicking this button here, it's going to keep those images in your processing, but it will remove such images from the next processing option you do until the next time you re-enabling them into your project. So now they're grayed out, so they're disabled from the project. So what it means is I can then generate the surface model and the terrain model, and it will only use the nadir imagery. So as an example, here, sorry for that, the overall surface model was generated at 5 times the ground sample distance, which is the optimal resolution. So you can leave those parameters as they are right now, and you're gonna have a surface model like this that was generated. From there, you can extract a terrain model, so it's going to remove buildings, cars, trees, and all those other elements. And then you'll also be able to see the footprint of those images inside the project. Then you can generate the ortho and the mosaic. And once this is done, and you're fairly happy with the DEM, the DSM, the DTM, and the ortho and the mosaic, and you want to generate your 3D models, you can then go back to the project tree and then re-bring back the oblique imagery, and then launch the 3D model generation, and it will include the oblique imagery to the project. The disabling and enabling function is also another thing you can do with the different orthos. So you can select the ortho, and all those ortho can be excluded or included into the project. So you can disable different orthos. Maybe if there's some images that are too much contrast or not enough contrast, and even with the color balancing they're still struggling, you can then disabling them from the mosaic. So it's the same principle, and you can also re-enabling them every time you want to include them again in your project. Here are some unique benefits of Correlator 3D. So we have unmatched processing speed. So Correlator 3D is a software that's mostly focused on the GPU. A lot of calculations are done directly on the GPU. Also, we use a multi-core CPU for a lot of our modules. No training is required, so we have different options for users. We have the automated workflow, which is a one-button click solution, but we also have some module by module for more advanced user if you want to have the fully control over your data. And we have unlimited numbers of images that can be processed on a single standard PC, and also everything can be scripted out within command line if you wanna have a smooth workflow. So you can launch your script and all the processing is going to be done from the project creation up to the mosaic editing and also the 3D model generation. Also, the software can be installed on some cloud-based instance such as AWS or Azure if it's a solution that fits your need. We also have flexible pricing such as the monthly, the yearly, or the permanent subscription. We have different types of license options. So the UAV up to 50 megapixel. We have medium format, and we have satellite and also full format camera. We offer node-loc and floating license. And also, if you want to get started with Coordinator 3D, we offer free processing for marketing purposes. And also, we offer free trials of Coordinator 3D. All you have to do is go on our website, www.simactive.com, and you can download directly your free trial from there. Also, if you have other questions, feel free to write us down at sales@simactive.com, and then it will be a pleasure for us to help you.